Hey guys, welcome back. We are doing array and hashing series, and the next problem in the list is valid anagram. So let's go to LeetCode. It's a really simple and easy problem. The description is just one-liner. I'm sure you might have already solved it and might be looking for more alternatives to solve this problem. So given to a string s and t, return true if t is an anagram of s and false otherwise. So you can ask your interviewer what is an anagram if you don't know, but here anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. All right, so I have taken the first example here, and what we really need to check is that s and t, which are both strings, if they are anagram, then you return true, otherwise false. So we just read in the definition of anagram is that all the characters in s have to appear exactly once in t as well. So basically each character needs to appear in s and their frequency also needs to match. So a brute force way of solving this problem would be, how about I sort both of them? So sort both of them, and since these are strings, so they contain characters, then sorting function will sort all the characters lexicographically, which means that if a comes in our alphabets before b, then that's how they will be sorted. So sorted form of s would be like this. So a, so all the a's in the beginning, then g, m, and r, right? So that will be the g, and we just forgot m, n, r. So that will be the sorted form. And how about this? Same way. So all these a will come in the beginning. So a, and then g, and then m, n, and finally r. All right. Now, if you see both of these, if they were anagrams, which they are in this case, they would be equal, right? They would be equal, both of them. So that's the brute force way of solving this problem. So simply just sorted s, so return, you will be returning sorted s equals to sorted t. But there is one more thing. You can have an extra edge case check if the length of s and t is equal. If it is not, then it's a false. They cannot be anagram if the length is equal, which means that there is some letter whose frequency or that letter doesn't exist, so that is the brute force way of solving this, and the time complexity for this solution would be big of n log n because of the quick sort, merge sort, whatever. This is the time complexity for those. Is there a better solution? Yes, of course there is. I'm sure you have written the better solution and you came for the brute force, because it's so simple, right? It's all about checking if the character exists in t, whatever exists in s, and also their frequency matches. So how about I will create char map, and then I will go through my s. So I can say s char map, and then I will go through all of these, and then I will store their frequency. So a appears basically 3 times, n appears 1 time, m appears once, and then g appears once, and r appears once. So that's the frequency check. These are the keys, and these are the frequency of each of those characters. So if this s and t are anagrams, then if I go through s again, and whatever the frequency I have increased here, incremented while going through this, I will decrement this. So for n, I will reduce this to 0. Then a, now it becomes 2. G becomes 0. A becomes 1. Then r becomes 0. Remember, I'm reducing it, the frequency, just like I must have increased when I was going through S. Then A becomes a 0, then M becomes also 0. So everything became 0 here. So you can either just check, if ever, you can just return true if none of these frequencies, either you didn't see the character as a key, or the frequency went in negative. If the frequency went in negative, let's say if here after M I had one more character called like A in this here, then I would try to reduce this 0, but now there is not even any frequency to remove that. So that is why I will return false. So immediately if I see a negative value in my map, then I will remove it. I will return false, right? So this will be of n time complexity, and space would also be big of n. That's the total number of, maximum number of characters in S or T between both of those. So let's implement. It's a easy solution, right? So if len S is not equals to len T, then you return false because they're not anagram. Here you will return true, but before that, let's create the char map, character map, initially empty. Then let's go through S. For ch in S, and we will be adding or incrementing the frequencies here. So for this ch dot get for the ch frequency, if you don't find it, consider 0 and then add 1 to it. Now for ch in T, if ch not in the map, then you return false, right? Return false. Or honestly, I'm just writing it so that like I might have deleted it. So what I was doing is, so this right here, negative ch minus equals 1, and if for this key, if the value becomes 0, then you delete for this ch. But another thing you could do is, let's test this out, and I will make the changes. Here you are just reducing it, and then you might have deleted that key because the frequency became 0. So next time you will not be able to see it. So that's a good check. So let's try this. I'm gonna zoom out, and I'll make some like a little bit of changes. So all right, we can submit it. Awesome. So what I was saying is, like, rather than deleting the keys, you can just check here if this ch not in char map, that's first thing, or that will short circuit if this is a different key that you are seeing, and so this should short circuit. And then here in this char map, this ch, basically the value here for ch is actually less than equals to you can say 0. If it doesn't exist, that's the same thing as like checking. But if it were used while removing like here, then also like we need to return false. But we are first checking it either doesn't exist, or its value has either become 0 at this point, it has become 0, and then you are again checking that, or it has gone into even negative or whatsoever. So I think this will be it. This should also run. So let's submit. Awesome. Same. Yeah, I didn't change anything with the time complexity. So let's just note it down. Big of n total number of characters, space complexity. We are using, so I'm gonna write k here, and k is the maximum number of distinct characters that you're seeing. And this, if it were just the small case English letters, then it would be big of this. K could be 26 if it were just lower case English letters. Okay, so let's mark this solved and see you guys later in the next problem.